Welcome to Aether United Interviews, where we have interviews with people within the blockchain as well as various esports. I'm your host, Brian Chang, and today we're joined by Patrick Barron. Patrick is a blockchain instructor at Fintech school and is the head of business development at Ambisafe, which specializes in the issuance of Ethereum-based financial instruments and related services such as ICOs and exchange integrations. Previously, he was a co-founder of Hitfin, an Ethereum-based platform that moves traditional financial assets onto the blockchain. He is a consultancy advisor to Blockchain at Berkeley, which is UC Berkeley's student-led organization with over 200 members that train blockchain engineers and consultants, as well as provides consulting services to Fortune 500 companies. We called him in today to help explain the intricacies of blockchain to the viewers here at Aether United. So, hello, Patrick. How are you doing today?
Hey, I'm doing excellent. How are you?
Sounds good. I'm doing fine as well. Just finishing up school, finals rolling around.
Well done.
Yeah, so blockchain is an intimidating term, and we called you in today to discuss to allow you to give us a brief education on the importance of this new technology and to allow our viewers to be more comfortable in using this technology.
Mm-hmm.
Yeah, thank you. And so moving on to our questions. How would you explain blockchain to someone who has never heard of the term before?
Yeah, so a blockchain, I will give you the more technical definition, and then I'll break it down into pieces because I think that's the best way to go about it. So a blockchain is a distributed database protocol, and it uses cryptography as well as a consensus algorithm to maintain a perpetually growing ledger of transactions.
Right.
And so to break that down into smaller bits and pieces, first off, you can kind of think of it as like a Google Doc, and everybody can see the entries of a Google Doc as if it's being shared across a team. So the ledger, and I'm specifically talking about the Bitcoin blockchain.
Right.
There's a number of different blockchains out there, but we'll focus in on that one because it was the first, and its underlying technology is used in just about every other blockchain. So if you understand it, then you're going to be able to understand the technology. But it's a distributed database. So the database is similar to the databases that we're used to that store all of our pictures and text files and these types of things, except that anybody has the ability to download an entire copy of the database.
Right.
So it's open, it's borderless, it's permissionless, and it uses public and private key cryptography in order to verify ownership of digital assets. And the consensus algorithm is a voting mechanism that the entire set of nodes use to come to agreement on who owns what. So it's a database. It's a database that's distributed across the world. Anybody can become a member of it. It's a protocol, so it's a communication method, and it uses cryptography to protect the information and to enable the transfer of the information by the rightful owners. And the consensus algorithm is what it uses to determine who owns what. So that's the voting mechanism. So at a very high level, that is what a blockchain is.
I see. All right. Thank you. And with your, cryptography and everything, blockchain is often praised for its transparency, like you said, borderless, etc., and its safety. How do they achieve this?
Yeah, exactly right. So the way that the Bitcoin blockchain achieves its ability to come to consensus is that everybody can see every single transaction since the very beginning. So you can think of the Bitcoin blockchain as being pseudonymous. So it's partially anonymous. What I mean by that is that everybody can see every single transaction.
Right.
Now, it may or may not be possible to correlate a particular address that a transaction came from or went to with a real world identity. So that's why it's pseudonymous. And because it uses the strongest cryptography available to secure the transactions, is almost computationally impossible for somebody to guess a private key based on the knowledge of the public key. So what that means is that if you control the private key to a wallet, to an address that has Bitcoin in it, it is your Bitcoin. You, by the laws of this protocol, you own those Bitcoin because you control it. The other piece is that the consensus algorithm is like, you can think of it as similar to pouring layers of concrete. So when a transaction goes through and the miners verify, the miners are the group of nodes on the network that are looking at the transactions and coming to agreement in consensus, using the consensus algorithm to come to agreement.
Right.
Every time they come to agreement, they add a new set of transactions onto the previous set of transactions, and they lock it mathematically. So what that means is that as a transaction gets further and further down, and that's called adding another block. That's where we get the blockchain,
right?
The block of transactions. And so if we take a transaction and it gets verified by the miners and it gets put into that block, and then another block gets put in on top of it, and then another one, what it's doing is that if you wanted to be a bad actor, you wanted to say undo this transaction that was 3 blocks ago, not only do you have to undo that block and redo all of the work that was associated with coming to the answer to that block, but you also have to do the next 2 blocks as well. And you have to do it faster than the rest of the network. So as a transaction gets verified, you can think of that as like pouring 1 layer of concrete, and then the next block, and then the next, and then the next layer, and then the next layer, and then the next layer. So it becomes exponentially more difficult to undo a transaction, and you would have to expend a tremendous amount of computing resources and electricity in order to accomplish that. Now, this is where the game theory piece comes in. Satoshi Nakamoto, who published the Bitcoin white paper, was a brilliant game theorist. And what Satoshi realized is that if you're going to expend all of those resources undoing a transaction so that you can defraud the system and cheat somebody out of Bitcoin that you sent them, you actually have an incentive to point those computing resources towards securing the network and being rewarded for doing so.
Right, because you would gain more Bitcoin in the process rather than losing or trying to gain back the Bitcoin that you used.
Right. In order to defraud the system, you have to expend computing resources and electricity. You can expend those exact same computing resources and electricity towards securing the network, and you can also earn Bitcoin. So it's there's an incentive in there for people to secure the network. So that's the cryptography is part of why it's so secure. The game theory aspect of how it all works together is the other reason why it's secure.
And that also provides the safety net for people who want to make transactions between in blockchain.
Right, exactly right. So that's the mechanism that's used to verify that somebody. So in order to, if I were going to send you 1 Bitcoin, what I would do is that I would initiate the transaction, and what the miners are going to do is going to look and see if I have access to 1 Bitcoin. If I have 1 unspent transaction, that's all it is unspent transactions. The way they're going to verify that is that they're going to look back and see if there's a record of somebody sending that of Bitcoin to me, and they will trace that all the way back to the genesis of that particular Bitcoin.
Right.
And I'll go ahead and hit on that. The way that Bitcoin is created and introduced into the system is by the process of mining. So as the miners verify the transactions, they look to see where all the Bitcoin went for that set of transactions. And then they're also doing computation. They're looking for a particular number. It's a random number. It's like a lottery. And so all they're doing is that they're just trying random numbers over and over and over again until they find one that solves the math problem for that particular block. If they're the first ones to solve that math problem and they mine that block, then they get what's called a Coinbase. That's a special reward that they put into the transaction block, which is brand new Bitcoin that have never been, they've never existed before.
That's the first block.
So that is every single block. Every single block that gets created, there's new Bitcoin that's introduced into the system. We know exactly how many Bitcoins it is. There's a set monetary policy. Originally, it was, I believe it was either 50 or 100 originally, and then it halved again. And now we're at 12 and a half Bitcoin per block. And then in about 4.5 years approximately, it's going to halve again until we get all the way until all 21 million Bitcoin are released. And that'll be somewhere within the year of 2140.
Something to look forward to.
Something to look forward to.